Got it.
So, all right. So it says we are live, and here we are. I am joined by another long-standing podcast companion, Mrinal Wadhwa. How you doing?
Very good, John. Thank you for having me. This is exciting.
Yeah, I'm glad that you're willing to submit yourself to this experimental interactive format for the audience. You know what you got to do here. You got to chime in and start giving us feedback and grief. Um, and we will be going through some countdowns today. We're going to talk IoT project success, and this is really important, I think. I mean, obviously, IoT is a buzzword you can take or leave. That doesn't really matter. The point is, connected devices, smart devices, all that stuff, that's an enterprise reality now, right, Ronald? And we got to do it right, not screw it up.
It's happening, right? Whether we like it or not, we may give it all sorts of names. There's the super popular Twitter handle, the Internet of Shit, right? It's
Right.
regardless of what we call it, right? It's happening. It's things around us in the physical world are getting digitized. There's value in doing it, both for convenience of consumers and for helping businesses save money, make safer environments, improve, reduce costs, all of that, right? So it's happening.
Yeah, and I think we're going to do countdowns. You're going to get a chance to vent on the IoT stuff that drives you a little crazy. I might participate a little bit, but full disclosure to the listeners, I've had a ridiculous week because my beloved car died, and I spent a lot of time in the car dealership this week and not preparing for this show. So, but we're gonna be counting down what bothers Mrinal most around IoT misconceptions, and we're also going to get into project success because one things I'm really trying to do with this rebooted show is to strike a good balance between kind of taking some shots at stuff that needs to be demystified, but also really looking at what it takes to pull off successful projects, because that's really why we're all here. And we need to sort of have a positive tip, and I think that's the one I want to take. I think with IoT, it's interesting because we could get sidetracked by consumer IoT, and obviously hackable consumer devices make headlines just about every day. So we could touch on that, but that's not really going to be our main focus. We're going to look more at the enterprise side of this. We're going to talk a little about your startup. We're going to save some of that to the end because if you can make it without pimping your startup too much, I'll give you a shameless plug at the end. But I do want to talk about it a little bit because I want our viewers to understand the background that you bring to this, because you're not just coming in as like, oh, I'm a newfangled IoT dude, like trying to make a big startup. Like you have a background in enterprise software, and you've worked on a ton of SAP projects, so you kind of know. You have this history of large scale products, so you know how products get into trouble with security and all that stuff. So tell the viewers a little bit about your background and kind of how you wound up in this space.
Yeah. So I have been involved in building large-scale distributed systems throughout my career at various enterprise companies. Started at EMC, then was at SAP for some time, then did a bunch of consulting work around the big data Hadoop space. And then I want to say about 8 years ago, or 7 or 8 years ago, I got deeply involved with IoT. Because I was hired into a business that was a traditional hardware company. They'd been building hardware since the 90s, and they wanted to transform their business from being a vendor of devices and sensors into a platform for connected cities. And that was a really interesting experience for me. I was brought in as CTO to kind of lead that sort of transformation of that business. And we ended up designing a IoT platform. The term IoT platform kind of didn't exist when we started. So everything was new. We designed a platform. We then deployed large number of sensors in several major city downtowns and had all sorts of pains and experiences in doing that. But these were systems that were doing, critical city infrastructure. So things like flood monitoring, traffic monitoring, streetlight control, et cetera, that are both cost savers and ways for cities to make the experience of people living in the cities better. In deploying and designing those systems, I have formed a strong view around why IoT projects fail, how IoT projects may be successful or could be successful, and of course, things like security, scale, reliability, dependability of systems like this. So that's why I'm here. And now I, about 2 years ago, joined my co-founder, Matt Gregory, in this open source startup. We're 100% open source code base. The company's called Occam, and we're building some tools to make IoT secure and safe.
Because no IT manager is going to sign off on any of this stuff without that. So, got to have it. So
yeah, I think that. Go ahead, John.
No, you first.
So I think in simple terms, right? A project is successful if it meets expectations, right? A customer gives you money and they have some expectations, and they expect the project to meet those expectations. And some of those expectations are kind of explicit and stated, like, hey, you should be able to do this, right? You should be able to measure. You should be able to detect when my machine's about to break down, or you should be able to detect when my pressure has reached a certain level, right? Those are explicit ones. But then there's always these implicit expectations. Even though the customer didn't say it, they expect that your cool new gadget isn't going to disrupt operations in their company, right? They expect that that thing is not going to expose them to ransomware or malware or downtime for a week, right? So a project to be successful needs to meet these expectations, and something's clearly wrong in IoT, because I don't know what the latest number is, but from McKinsey and others, there have been these numbers of 75% of IoT projects fail, right? Well, that's a ridiculously bad number, and something's not right. And I'm really curious about what others think as well around how to fix it, but I certainly have strong opinions on the approach.
Yeah, let's definitely get further into why IoT projects fail and how to avoid such types of scrutiny. And I also want to get into what the winning business models are, because ultimately this should be a business conversation, right?
Mm-hmm.
So we'll get into that as well. For our first countdown, we're going to be doing your top 4 misconceptions about IoT. I think a lot of them are around security, but you can take it wherever you want. Give us number 4. What misconception about IoT drives you nuts?
I see. My system is secure because I'm using blockchain. I'll start there.
Oh,
I know that's
boy.
a controversial topic.
Oh boy. All right, we're already in a blockchain. This is good.
My attempt there, my hope there is that we can kind of bury this one on the side, right? Blockchain's a tool. It's useful for something. We're still discovering what it might be good for, but it's a simple tool. It's a database that multiple people manage. And yes, there's a lot of technicality around what is the guarantee you can, what exact security guarantee you could design into that design of that distributed system that a lot of people manage together. But at the end of the day, it's a table that to edit it, 3 out of 5 parties have to agree before you can edit it, right? They have to agree on the rules of when you're allowed to edit a row in that table. And that is a useful tool. It is not a panacea to solve the world's problems. It's a useful tool in some small subset of applications. For instance, in the IoT realm, certain people are looking at, or even our company has looked at in the past, around designing a table which stores identity and public keys of devices in a shared manner, because that's an important data point, that if only one party is managing that table, that one party can override that entry in the table and override some device's identity or some person's identity. So in certain small subset of use cases like currency, like identity, there is some applications. But just saying I use the blockchain so my IoT system is secure is just a weird distraction, and we should all just ignore it.
Yeah, it kind of seems like, I mean, I'm glad you brought up blockchain because it's certainly a pet peeve of mine as far as the amount of hype, but it seems like a distraction, right? Because we're trying to settle this issue of how revolutionary blockchain is. And it's the wrong conversation in the first place, because we should never begin these project conversations with, I want to try a sexy tool out. You know, we should begin these conversations with, what problem are we trying to solve? And then what tools work for that problem. It's really going to vary, right? And look, I mean, if I have to fast forward a number of years, I think blockchain will have a use as one tool in a toolkit for things that enterprises want to do, along with other distributed ledgers and there's so many variations that are going to emerge, I think. So you're going to have to understand the use cases, and a lot of them are very nuanced. So to me, it's like, well, okay, let's just I agree with you. I mean, it's fun to talk about blockchain because everyone's got an opinion. And hey, if anyone watching wants to throw out their blockchain opinions, you're welcome to do it. But I don't think that should be our focus, because that's not what these products are really about. So,
yeah. And you know what's a cooler tool? Cryptography. Cryptography, the field, which blockchain is just one use of cryptography. Cryptography as a whole is a much cooler tool. If I was just geeking out and saying which tools to apply to IoT, that's the more interesting tool than, one interesting way of organizing database tables.
Right, absolutely. Okay, cool. So let's go on to your number 3. What's another misconception that you run into that makes your life harder?
Well, my life's all around IoT security, so I hit a lot of these security related ones. So everyone will tell you their system is secure, right? So let me explain what I mean. Because IoT security is such a big objection that every customer raises it, most vendors in their very first sentence will tell you their system is secure by design, right? And so everyone's saying their system is secure, which means all of IoT is secure. Yet, my news feed is pretty much every day several problems in IoT. Like the latest one was just yesterday, GE had several radiology equipment with some default password or something like that, right? So it's all over the place. Clearly, IoT isn't secure, but the entire vendor ecosystem is out in the world saying our stuff is secure by design. And that's definitely a pet peeve of mine, because if you scratch the surface in most of those scenarios, you find that things are bad. They're bad for a reason, because it's challenging, right? That problem is pretty challenging to solve, because the traditional tools that we've used for internet security don't necessarily just translate over to IoT security. It's a new set of problems, a new set of threats, which needs a new set of solutions designed to address those threats. And we have not reached that level of maturity yet as an ecosystem.
Yeah, I was thinking you might be bringing up some of the edge hype too. It seems like now it used to be you're cool if you're in the cloud. Now you're cool if you're on the edge. But what does that actually mean?
We'll take your stuff on the edge. Everything's running on the edge, right? That's my snarky. I sit through several presentations every week, which are all about being on the edge. So yeah, All right. Well, here's my view of it, right? The reality is it's happening. It kind of makes sense to not compute everything at a central place.
Right.
It makes sense to distribute decisions out to the world, because what you get out of that is lower latency. You get faster decisions. You can also get better context, because you can have more sort of real-time context when you're taking that decision. And there's an opposite benefit to the cloud where you can have more historical context, more broader context across multiple machines, right? So, IoT systems or edge systems are doing three things at a high level. They sense, they infer, and then they act on whatever inference they arrived at, right? And it started out with a lot of IoT started out with, well, actually, before it became internet connected, the machine started out with doing all three things inside a tiny microcontroller, and there was no connectivity, right? Sense, infer, and act was inside the microcontroller, no connectivity to the world. And that worked, but we learned that it wasn't very precise. It couldn't apply broader context, right? Because it was this isolated tiny machine. So then with IoT, over the last 10, 15 years, we realized, well, if we take this data and we send it to the cloud, to some central place where we can have a large database of context and business rules and machine learning models, we can improve accuracy, we can improve timeliness of decisions, we can improve like the basis of a decision itself. So it kind of makes sense. And so we started moving everything to the cloud. But that led to other problems around, well, now latency is too high for a lot of use cases, and
right.
The security obviously becomes a problem because you're now that information is traveling over the network and can be tampered along the way. Instructions are traveling over the network, so if an instruction is tampered, your device could behave in weird ways, right? So yes, it kind of makes sense to now do it over the cloud. And this whole edge computing idea is, well, okay, now to reduce latency, let's move these inferences closer to where the sense and act is happening, right? And that makes sense to me. It leads to, I think, better systems in a lot of contexts. So that move is happening, but it's not, a lot of the picture that is painted around edge computing is very sort of general purpose. We'll move containerized workloads to the edge. And it's not very clear for what applications. I think a lot of this edge computing discussion needs to be done in the context of specific applications. Kind of, it makes sense to do it, for example, in transportation and autonomous driving. It makes sense to do it to improve accuracy of sensors. So it's like all buzzwords, there is some value in there, but a lot of the market buzz is very fuzzy and not very coherent as usual.
Yeah, and I wanted to ask you about this other buzz thing that drives me nuts is 5G, because in the US, the telecoms are like bombarding consumers with basically nonsense about 5G that doesn't even match up with the infrastructure we currently have. But do you think in the context of some of these industrial use cases that 5G type of broadband upgrade makes a difference for some of these edge scenarios, or is it kind of like not a big deal in the evolution of things?
I think it may be, right? A lot of, so we talk about these big picture items like edge computing, or, everything will be connected through IP addresses, etc. The reality of a lot of IoT is that it's kind of stuck at step one. And all of these pictures that get painted in marketing material are step 95. And most IoT is in POCs and just never gets out of POCs. So connectivity, like all of that 75% of projects fail, is most IoT just like, some team with a bunch of Raspberry Pis hacked together a tiny proof of concept, and then that thing never became real, right? That's the reality. So yes, if a lot of things come together, better connectivity is definitely a valuable thing when it comes to scalability of some of these solutions. And there is, in fact, better connectivity in. I don't know if they have covered NB-IoT specs under the 5G umbrella, but if they have, that is an interesting protocol and has some very cool applications. But so do other alternatives to that protocol, like LoRaWAN or Sigfox, right? There are lots of alternatives there. But I think the reason those conversations, at least in the IoT context, don't get me interested, and I suspect don't even get end customers interested anymore, is because they've now seen the reality of which is, projects just don't get started, right? And they don't sure, you did a cool POC and you made a good presentation to some conference, but that's where things are stalled for a lot of IoT in the real world.
Right. Got it. So if you're stopping in now, talking with Mrinal about IoT misconceptions and project success, the chat is a little quiet today, so I don't know if you guys are goofing off on holiday shopping, but it's time to start chiming in and keeping me on my toes with the questions. But in the meantime, I'm never short of things to ask Mrinal, especially in such an overhyped area. We're going to get back to our countdown of your misconceptions. But before we do, I just want to ask you a little bit more. Ooh, we got a LinkedIn user. Yeah, he's one of our favorites. Are 5G IoT devices fitted with eSIM cards open for local mobile networks? Are they available now? I don't know. I don't think Mrinal is selling those currently, but
I haven't seen one. I have seen definitely prototypes of various sort of NB-IoT like systems, but I haven't seen anything. But I'm sure there are others listening in that might have better context there. I haven't seen one that's available.
By the way, this LinkedIn user is staying up late for a show. Thanks for staying up late. I know you're on a different time zone. And sorry, the last week's show was even later. Had something I couldn't get out of. So anyhow, we moved it back to at least an earlier time for you. So good to see you back. So I wanted to ask you a little more about IoT project failure. Because when I see failure rates that are that high, it's actually, look, I mean, a lot of failure rates in a lot of technology areas are pretty high, but it is a little bit concerning. And it just want to make sure, like, I don't think it's that the tech is not mature enough, because I think a lot of this tech, putting blockchain aside, I think a lot of this other tech is mature enough. So if the tech's mature enough, then what are the cause of these failures, in your opinion?
Yeah. I really like the comment someone left around fridges and food.
Yeah. Remember when they introduced us as fridges that can order your food automatically? Well, yeah, and who can forget Mark Benioff's smart toothbrush, right? I mean, we haven't even gotten into smart devices and the consumer impact of those and the hackability, because that's not going to be our focus today. But it does lend itself into the hype of the conversation for sure. Anyway,
I have 4 smart toothbrushes, by the way, that I've not opened because our dental insurance that we have at the company, they will mail you one for free. And essentially what they wanted to do is they want you to tell them how many times you brushed your teeth. And I have not opened even one of them, but I do have them somewhere lying around. Anyway,
I think it'd be pretty scary if you came home one night and they were talking to each other. then they would really pass the intelligence test. But anyhow, back to the failure. What do you think is the source of that?
So here's what I think, right? I think that we made it really easy, or the community as a whole, over the last 10 to 12 years, it became really easy to prototype IoT products, right? The Raspberry Pi came around, Arduinos came around. These were tools that made it really easy to build a prototype of an internet connected device. And that saw this renaissance of people thinking about use cases and trying to apply and imagining up things like, connected refrigerators, etc., or toothbrushes. And they could even put together a prototype pretty quickly, and they could get things into production pretty quickly. But these fundamental, what I have seen happen in real world projects is that the POC goes pretty well. But when the customers start asking questions about like real world, can my business depend on this solution that you're selling me? That's where things fall apart, right? Because the moment they start asking questions around dependability on these or depending on these systems, then the things get real, right? Then they'll ask questions about, well, how do I scale this to if I'm doing truck monitoring and I'm monitoring my trucks for whether they're operational or not, how can I scale this to a fleet of 10,000 trucks? And then that's where things start to fall apart, because the tooling to take that prototype and deploy it at large scale is still not quite ready, especially deploying it at large scale in a way that is dependable. And my definition of dependable is reliable in extreme conditions, secure, private, doesn't reveal my proprietary information, etc.
So you think there is a tooling issue that's holding some of these projects back then?
Yeah, I absolutely think so. I think and that's where a lot of times what happens is that people will take tools they know. So because it got easier to prototype IoT, we saw this influx of traditional web app systems people or systems integrators in the enterprise now became suddenly, I'm working on an IoT project now, right? And that cohort of people brings a lot of expertise around how to collect data, how to analyze data, how to run processes, etc. That's their core expertise, but they're unable to make these when faced with these real world challenges of, my device is sitting on the street or it's sitting inside a truck. There's no data center boundary around it. Anyone has access to it. How does that break my system? Those kinds of challenges are very different class of challenges that community isn't quite prepared for. And so how do you address that? Is you address that by some experts taking what they've learned and turning them into tools that are reusable and that democratize, scaling of IoT systems for these large community of developers that want to build systems.
Makes sense. Any insight into medical health devices that could share data with clinical trials?
Data with clinical trials. So there are lots of use cases. I don't know if you're talking about from a use case standpoint. I think there's plenty of people exploring those kinds of use cases around medical data. It is definitely an area where security and privacy is critical. Even the most cutting edge of designs around IoT security in the medical setting can be very not sufficient. So I'll take a very simple example, right? Let's say I have a connected watch, right? And this watch can connect my heart rate reading. Let's say my use case is that I should be able to see my heart rate reading on my phone. And they can't, when the company sells me this device, they go, yeah, so look, you can see your history of heart rate readings on your phone, and no one else can see it, and you can monitor your heart rates and detect health based on it. But the reality is that the company that sold me the device can see all of that data, and there isn't a good technical design yet that would allow that company to offer this service without revealing the data to their servers. And the reality is that the infrastructure that typically goes behind all of this, it's not only one company, it's like several related partner businesses can all kind of see your data. And so very quickly you end up in this, my vulnerability surface is so large that nothing can be controlled. And so everything starts to leak. And then they go, okay, another cooler use case would be that if you could reveal this heart rate data to your doctors, that would be very nice, right? And now suddenly the hospital's ecosystem of developers and partners, everybody also is now part of this cohort of people that can start seeing your data, right? So while a lot of people are experimenting with use cases, my personal experience has been that the infrastructure and tooling needed to address that isn't quite mature. A real solution that would be secure and private would be that data from my health device comes end-to-end encrypted to me, and no one else has the keys to see it. Mm-hmm. And the protocol can prove to me, at least to experts, that this cannot be exposed to anyone, right? And then when I reveal it to my doctor, the protocols underneath ensure that the only party I'm revealing to is my doctor, and not some ecosystem of partners that can see, the doctor's patient data.
Bottom line, healthcare scenarios aren't ready yet. Let's avoid those. Use healthcare data sharing with extreme caution. And on we go to the countdown. We're moving a little slowly through the material here, but that's okay. So number 2 misconception from you that bothers you about IoT.
Since I'm continuing down the security rabbit hole, I'll continue down that path. What's very common, and I kind of alluded to this already, what's very common is that customers or vendors will say, our IoT system is secure because we use HTTPS. And this is a symptom of not understanding how some of these, in what threat model a particular protocol was designed for. HTTPS was designed for a very different kind of system from IoT, right? So HTTP is designed for securing the web, and it only authenticates the server, and the server authentication mechanism is also reliant on a tree of trusted parties called your certificate authority tree, right? Or the web PKI. And that infrastructure works in browsers to authenticate servers. It doesn't work in a device to authenticate something. You could make it work to authenticate servers, but actually most device and server communication is two-way communication, right? So even the simplest sensor that is sending some sense data to a server will have a mechanism to receive a software update. So it's always bidirectional communication. And because it's always bidirectional communication, you need mutual authentication in all these systems you design. Right. To have mutual authentication, that's where the problems get really bad, because you have, hey, I have one server and I have 100,000 devices. So to have authentication, I need to store secrets in 100,000 devices. Mm-hmm. So that only that one device can prove to me that it's that device. And that's where things get the worst, right? That's the root cause of IoT security problems, which is key management at scale. Right. Distribution of keys, rotation of keys, revocation of keys, all of those are the real world problems. So what happens is a lot of vendors, customers that I've come across, they'll kind of convince themselves that their system is secure because it uses HTTPS, because that's the advice that a lot of people have been sort of echoing in the web world is if you want a website that is secure, use HTTPS. But you don't get a secure IoT device just because you started using HTTPS.
You got a little kudo there. That explanation of HTTPS is one of the best I've heard. Well, why do you think I had Mrinal on the program, dude? Guy knows what he's talking about.
There were a bunch of other comments. I don't know if I missed something.
Yeah. I don't want to get into all of them because, frankly, we're going back to blockchain, and we already dispensed with blockchain earlier. We're not going to be talking about blockchain much more on today's program. Sorry. It's an immature technology. It's not ready for this yet. But anyway, what if you could store a trial volunteer database and use blockchain to anonymize the source personal identifiable data? Can you dispense with this fairly quickly so we can move on? Because I just don't want to get into blockchain again.
A blockchain does not do anonymization. A blockchain is simply a table that multiple parties are managing. And It has nothing that helps with anonymization. You could use cryptography to anonymize. And this is where I actually have a good example. Recently in the news was, the Google, Apple COVID exposure notification protocol. That is actually a really good protocol. And it uses cryptography to solve some problems, not all problems with that use case, but some problems of privacy and security in that use case. And I hope to see more such cryptography-enabled protocols to become popular. To give a simple example, the COVID protocol is really complex, but to give a simple example, Apple has a protocol called Find My, which allows you to find a lost device, right? So if you lose your Apple phone, you can look it up on a map and it'll tell you that someone else saw your phone in the park. How does it come up with that information? Is that when the phone is lost in the park, it starts transmitting a public cryptographic key over a Bluetooth, and nearby devices capture that key. They take their location and encrypt it for that key and upload it to Apple's servers. And now you can discover it. But what's the nuance? The nuance is that in that model, Apple's servers are not tracking your location at all times. Versus you take the same solution from one of these tile vendors that sell you these tiles that you can attach to your backpack or a phone, or even from Google, the same solution of help me find my lost device results in Google or Tile or whoever tracking the location of your device at all times. So cryptography is a very cool tool for us to build protocols that fundamentally, computationally guarantee that this information is not revealed, and still deliver these use cases. So cryptographic protocols, I am a huge proponent of, and our company that we'll talk about later is actually investing a lot into building systems like that. But a lot of times, because blockchain was a use case of novel cryptography, people conflate what blockchain can do with what cryptography in general can do. And blockchain cannot anonymize. Cryptography, if used correctly, could help with anonymization of certain data.
Yeah, and then there's the comment around then you could reward users via micropayments on how their data is analyzed. I don't want to get into that now, but I will say that on the consumer side of these things, absolutely, I think proper compensation for use of data is a valuable and underused tactic and needs to be more prevalent going forward as opposed to advertising based.
Can I say something about that? Right. So before that happened, before that vision of people should get paid for use of their data can even be realized, people need control over what data about them is being used or can be used.
Right.
And current designs of systems don't have that control. So the in security, there's this law, back in the 80s, there was this principle introduced, or 70s maybe, called the principle of least privilege. That's what Unix security is designed on. The idea is, or in military circles, they use the term need to know, right? Only reveal information to whoever needs to know that information. It's like a basic fundamental principle in security. Cryptography and encryption is our only tool to build that control. If you don't have cryptography and encryption, what you have is a system where everybody can see or manipulate everything, all pieces of information that are flowing in the system. So by using cryptography and things like end-to-end encryption and mutual authentication, what we get is control over who should see what data. And then from that, we can build control over, okay, if I am revealing my data to John, I'm going to reveal it only when John pays me for it. But if I don't have that control, then there's no way we're going to get to a world where I get paid for use of my data, right?
Yep. One more comment here. He agrees completely, trying to understand the link of blockchain and cryptography. But okay, we can stop this conversation and move on. Thanks for that, because we are going to stop this conversation and move on. You'll find Mrinal's an accessible fellow, so I'm sure, given your know-how, I'm sure you guys could have an interesting mutual conversation about that at some point. And I don't mean to give it short shrift here. It's just that I have some other things I really want to talk with Mrinal about, because we really wanted to focus a little bit on IoT project success in the enterprise space. So I want to get there. Okay, let's get your final misconception out of the way. Let's run through that pretty quick. You have one more, right?
I have in all of this forgotten what my list was. What did I have up there? Oh, yeah. The number one I had was, well, I don't need IoT security. It's just a bunch of sensors, right? It's out there. It's fine if they send me. You would be surprised how many times I come across this, right? So what people are saying is, it's just some input information. Why do I care if it's secure? Well, you care if it's secure because you know, like if you're doing something valuable with it, if that system isn't secure, what you're getting is garbage, and what you're producing is also garbage. So what's the point, right? In security circles, there's this problem called the Sybil attack, right? Which is that if you can't authenticate where a piece of information came from, that remote party could be replicated with millions of spoofed replicas, and they would all look like information that originated at your source, right? So if your only authentication of your sensor is its IP address or its MAC address or some UUID that you gave it or some name that you gave that sensor, then if your use case is valuable and useful, there is motivation for someone to spoof that thing. And when they do that, you have garbage. More so, those sensors may need software updates. So you end up adding, some kind of software update mechanism to it. And so your thing has, a username and password. And suddenly that thing is an attractive machine to convert into a botnet participant. And that's how you end up with, malwares and ransomwares, etc. Yep. So even if you have a sensor and it's just a sensor, if it doesn't do security, you're probably going to end up in some trouble because of it if you leave it running for a while.
Yeah, and my number one would have to be, and we're not going to spend time on this because I want to move on, but would have to be, I think we need a much higher bar for when we use the phrase smart device. I think smart should be a high standard, not something you can throw around on any toothbrush and refrigerator. In my opinion, smart implies the ability to learn. If you can't learn, I don't see how you're smart. I think you're just connected to the internet. That's different. It's totally different. Anyway, just a personal issue that I have. But
Absolutely.
If any of you guys have IoT misconceptions and buzzwords that are bothering you, please throw them into the chat. But I actually want to get into your keys for success, but I wanted to ask you about sort of killer apps is the wrong phrase, but like in terms of industrial IoT, what use cases do you think are most compelling right now? I mean, the one that always jumps out to me is predictive maintenance, just because, you have equipment, and especially in the COVID area, that's very, very difficult to supervise and also to fix. Whenever I do tours of shop floors and stuff like that, there's invariably a huge, expensive, and usually about 20-year-old piece of equipment that's worth like more money than like everything I own. And if it goes down, they're screwed. And very few of those machines are connected to anything and have any kind of predictive. And in my mind, when I talk with those folks, they're always super interested, but they're not like there yet. But so that's one use case that jumps out at me. But I'm curious from your perspective, where do you see the real action as far as what can be done today?
So yeah, I think predictive maintenance is definitely, if not the top one of the top few use cases in enterprise scenarios. And it is incredibly valuable because it prevents downtime. It can lead to lowered maintenance costs. It can increase the longevity of that super important asset that people typically have. I had a really cool story of predictive maintenance, I think on Tom Rafferty's digital supply chain blog podcast. But he was talking to someone from, I don't know which company they were from, but they told about trains and this company that makes the wheels, the steel wheels of trains. And the traditional approach to maintenance is, check the wheels at some set periodicity after every trip of the train, etc. Right? And you check whether they're okay, and if they look okay, you keep the train running. But that leads to sort of unexpected downtimes, right? Because the load of every train is not the same. The length that every train travels is not the same, or every wheel deals with is not the same. So there's so much variance in how much stress each wheel is exposed to that you can't possibly get a good maintenance out of just doing it at a set frequency. If you flip that to detection, and so that's this company that he was talking to, or this person he was talking to, was describing how they were measuring flexion and torsion of the wheels and detecting cracks, you can then kind of just in time respond to these scenarios. You can even predict that, okay, in these many miles, I will not be able to operate on this wheel anymore, and you can kind of react to that, right? So what the impact of all of that is, you don't have downtimes. You can plan when you need maintenance. You can react to as things are building up to a downtime, like a train stopping or something. You can proactively take measures to avoid that situation. So like what I liked about that example was it was literally the get the trains running on time example. So
Right.
I thought that metaphor kind of applies to a lot of industrial equipment, whether it's like a CNC machine at a company or it's a pressure pump or something. There's a lot of maintenance related scenarios that make a lot of sense. And another thing that's interesting there is that the return on investment is really easy to conceptualize and visualize in enterprise scenarios versus consumer scenarios, right? So in consumer scenarios, the cost of a connected device is, let's say, 5 times the cost of an unconnected version of the device, right? If I buy a connected lock, I might pay 5 times more, 10 times more sometimes versus a dumb lock, right? And so the return on investment on that lock is very hard to visualize for an end consumer, right? Because is it so much better to get a connected lock? Maybe not, right? But in an enterprise setting, especially these maintenance use cases, the return on investment typically becomes really easy to kind of justify. And so I think that maintenance is an awesome one. Another use case that in recent times, I think is gaining a lot of traction is sort of remote monitoring of status of things, right? So instead of people having to visit to check on status and do an inspection for maintenance purposes, etc., they can do those things remotely. And that's a pretty cool use case. In manufacturing, there's also a lot of like robotic arm type things that are now starting to get connected. And the difference is there were robotic arms since the 80s. I think 80s or 90s, people have been doing some amount of automation with arms of some kind, right? But what's nice about connecting them is you can improve their precision and you can apply them in better scenarios. So if you connect them, you can apply machine learning to historical information. So if a arm is making decisions based on vision data, you can improve the accuracy of that vision data. So you might have, like in an industrial setting, you might have, a robot picking up boxes and placing them on pellets. Where if you add vision to it and you add machine learning to it, you can turn that into the robot can decide which boxes to place in which sections and which pellets, right? And that makes a lot of difference in terms of like applicability of those use cases. Maintenance definitely predictive maintenance definitely at the forefront of these use cases, but there are all sorts of use cases around automation and even failure detection, those kinds of things.
By the way, I like your use of the word connected because I like that much better than smart for a lot of these devices. I think connected devices is a better terminology that is more real for what it is. We had that comment. I just put it up on the screen for a minute because it blocks our entire faces, but it's the analogy of airplane engine maintenance, where during this time there are opportunities to maintain airplane engines, which you will know has improved hugely with using tools and robots to fix issues with engines that would previously require months of effort. Absolutely.
Yep.
We want to go through your keys to successful IoT projects, and we won't probably be able to get to all of them in our remaining time, but definitely want to get to a few of them. And one thing I did want to mention that's on my mind, because you brought it up in a few times, I think, in these examples, and one of the real disappointments, I think, around like not getting past the POC phase is, to me, it's the data platform that starts to make these things exciting, right? So to your point, being able to pull data from all these devices, do exception handling scenarios, apply machine learning and predictive trends. So to me, like, the more you're thinking in a data platform context about these projects, the better off you're going to be in the long run versus just an isolated POC in one factory, for example, or in one project setting. So.
Yeah, absolutely.
I don't know if that made your list, but that would be on my list. So.
Yeah, no, I absolutely agree. I think it's this, what is the business trying to achieve, right? What is tangible improvement in our current way of doing business that may be enabled by this IoT use case, or even smart connected device use case, right? There is definitely an opportunity to mix learning type of models with just pure connectivity, but you get plenty of value just from pure connectivity, right? So it's not just because even if it's pure connectivity, the amount of information a single device has is significantly smaller than the amount of information a collection of similar devices may have, right? So even if you're not applying any kind of machine learning, you get more context. You may get more business context in a remote like decision inference location than inside the device. So connectivity itself can be very valuable, but adding the ability to learn based on inputs either from that device or devices around it or other contexts can definitely be very valuable. But at the end of the day, it's all about what data am I collecting and what actions am I able to automate. And actually, I didn't mention this in my pet peeves, but one of the pet peeves about IoT is a lot of people just focus on the sensing aspect of IoT and forget about the actions aspect of IoT, right? In my mind, it's sense, infer, and act. And even if you have a pure sensor, there are still some actions like applying the software update. So it's always sense, infer, and act. And it's important to remember all three of them. But the act is about applying decisions, and sense and infer is about making those decisions wisely with the right kind of information. And having the right data platform that can actually function in these environments where, yes, you want some of the computation to move to the edge. So how do you move your contextual data to the edge? How do you move learned models to the edge? Those are all important questions if you're going to build this smart ecosystem of connected products that are actually smart.
Absolutely. All right. So your keys to successful IoT projects. Why don't you have a look at your list for a moment there and see if there's any that we haven't touched on at all? Because I imagine we probably hit on a few of them during the conversation. Are there any that jump out that we haven't hit on?
Yeah. No, I'm looking at the list, and I think because I talked about some of this, I think we touched on it. But here's the general point, right? A lot of the marketing around IoT tends to paint the step 100 picture or the step 95 picture. The real world is still struggling with moving from step 1 to 2, and so that's why we are in this like POC hell, right? We have projects that can't scale beyond certain small POC settings. To change that, I think, well, of course, there are experts in project management and better expectation management and helping customers understand all of this better. All of that is needed. But from a technology standpoint, since I'm the technology person in this discussion, I think from a technology standpoint, it's important we get past certain very basic hurdles. The super basic one is, things should be mutually authenticated. There is no way around that problem. Things should be end-to-end encrypted, otherwise we don't have least privilege being applied. There's no way around that problem, which means we need unique cryptographic keys in all devices. Again, no way around that problem. We have to provide easy tools that solve that. Once you have unique keys in all sorts of devices, you have to be able to rotate those keys, revoke those keys, manage them like any secret, like your password, right? You need to be able to change your password every few days or weeks or months. Otherwise, that password gets stolen and gets broken, right? So all of this is to say that traditional granular security authentication authorization controls aren't quite yet mature for IoT. Without that, we can't have security, we can't have IoT that is dependable. And I believe one of the reasons projects fail is this. There are, of course, other reasons, right? So clearly my bias in this is obviously clear in this conversation, but there are obviously other reasons around, skills gaps, right? Which is like a lot of these projects are SIs pulled in to execute some use case. So now SIs tend to have really good context about the business solution, and they'll have good expertise around making the business solution, but they tend not to have the expertise needed for the IoT-ish aspects of it. They don't typically have a lot of hardware background. They don't understand radio networks. They don't understand security in IoT too much, and that's where they stumble, right? So you have this big high-level picture and some block diagrams that show, this is the cool integrated solution we will have, but it doesn't succeed because the foundation is weak.
And I usually don't do plugs for Diginomica articles during the conversation, but if you do a search on Diginomica Pilot Purgatory, you'll find a really cool article from Anurag Garg of Plex. It's called Manufacturers, This is How to Escape the Perils of Pilot Purgatory. And he gets into that point that you've been talking about, which I think is really important, which is you're getting stuck in these pilot phases and that's not working. So anyway, it's a really good discussion to have. We can't cover all of that today, unfortunately. Anything else you wanted to cover from your keys to IoT product success? Then we're going to give you a chance to talk a little bit about your company, but I want to give you a chance to see if there's anything else you left out there.
So since there is obviously a collection of things you need to get right to have a successful IoT project. But since I've spent the entire hour just focusing on the security aspect, I'll say that to have good security, you have to have a good threat model. And this is where things typically fall apart, right? They don't even get started the right way. So the idea of a threat model is that there is a collection of things I consider as bad things in my system. I need to make a list of what is that collection of bad things. And any project in IoT, I think, should start with that, because IoT security isn't well understood and well defined. If you're building a web app or a mobile app, you don't have to start with that, because that problem has been solved for you by someone else already. And it was a team of literally thousands of people solving and designing the threat models and things needed for TLS to work on the web, things needed for the public key infrastructure of the web to work, all of the things needed for browsers to work correctly, sandboxing, etc. All of these are solved problems. But in IoT, they are not solved problems, which means if you're getting started on an IoT project and you care that your system is dependable, and to be dependable is secure and private, if you're targeting consumers especially, then the very first thing I think you should start with is a threat model of what all can go bad in my system, and what is my system doing to help me against those bad things. That I think is key to having a successful IoT project.
Cool. Before we get to your company part, we do have another comment. Another scenario, the speech to text and horrific Alexa, Siri, Google analysis. How do we turn that into IoT where someone asks something and the device understands what is being asked? The reason I held off on the question is because I wanted to focus a little bit on the enterprise project side of this, but we can do a quick answer to this one if you have any thoughts on that.
So I have another scenario, speech to text, some horrific looks. How do we turn that into IoT where someone asks something and device understands what is being asked? Well, it has to be speech to text, but it could be speech to text in a better way than it currently is. And I think Apple Siri is actually doing some things in this area. I am not sure, but I know for sure Google and Alexa are not, Amazon are not. Essentially, there is a way to do machine learning in a federated way. And Google has applied that to some of their applications. They have this whole set of like comic series on TensorFlow federated that you should check out if you get a chance. TensorFlow is a framework to do machine learning by Google. But essentially, the use case they applied it to was our keyboards on our phones learning what we type, right? So everyone types different things, and we make up words and we type them. And so what Google wants to do is suggest to you what you're about to type. One way to build that system is to collect everything I type. Another way to build that system is, and then learn from that. Okay, 500 people type the same word. So for the 501st person, I will suggest the word when they type the first two letters, right? That's how machine learning works. But if you collect all the data that everyone is typing, similarly, if you collect all the data that everyone is saying, which is Alexa, Siri, and etc., then you create this honeypot of what everyone said in the world. And that has, of course, good and bad use cases, right? Instead, if you flip that around and you learn, you still build a model of which words are being said often, but you learn in the device and you only communicate the learned information and you don't communicate the raw data. You can still have the nice convenience of good autocorrection without everything everyone said being collected. And Google has made it work with Google Keyboard. So one would argue that there is a potential to make it work for speech as well, because the use case is exactly the same. I think that kind of like federated machine learning is a really good, optimistic area of research in this space.
You're getting more props there. A great introduction of IoT for me. Thank you so much. So yes, absolutely. And I think the nice thing about what we discussed today is there was a lot of background information, but we also got into some pretty advanced stuff in certain areas too. So that was kind of a nice mix. Okay, you made it more than an hour without plugging your startup, and I'm gonna now give you the shameless plug opportunity. What part of all that we've been talking about today? What part is Occam trying to solve?
Okay, so what we realize is that there is clearly a tooling gap, right? Security, privacy, and trust are application layer concerns. A application developer knows which piece of data should be exposed to which entity in my system, right? That's application layer knowledge. But our traditional means of doing security has been focused on the network layer. And applications are moving further and further away from the networking infrastructure. As more infrastructure gets virtualized, as more infrastructure moves to the cloud or even edge environments, the application developer has very little visibility into or control into what's going on in the network layer. And what that does is it creates this impedance mismatch, if you will. It's a mismatch between what should be secured, trusted, and private, and what the network topology is, right? So that's part of the reason a lot of systems are insecure. So one of the things we have done is build a open source collection of programming libraries that you can use to build an end-to-end encrypted communication channel at the application layer, regardless of the network topology. So if you're used to something like WhatsApp or Signal, where if John and I are exchanging messages, the messages are end-to-end encrypted between John and me, and the server is just a router. Similarly, if I have a connected light switch in my house and I have a phone that's turning that light switch on, ideally, this trust should be end-to-end between my phone and the light switch. But in reality, in most IoT systems, this trust is via some server. And the server can totally eliminate my phone out of the picture, and the server could, on its own, turn the light on or off, which means that if the server is hacked, someone could control lights on and off in lots of houses. And that's not a good thing, right? So by having end-to-end encryption in these systems, we bring back control. We bring back the principle of least privilege to IoT systems. And this topology is a very simple topology. Real-world IoT topologies can get really complex with lots of different networking protocols and lots of different multiple hops of networks. And even in those scenarios, you don't want your data to be exposed to intermediaries in the network. You want end-to-end application layer trust and control. So that's layer one of the Occam solution, which is end-to-end encryption and end-to-end encrypted messaging. Layer two of the Occam solution is how do I deal with unique cryptographic keys in all devices, mutual authentication in these end-to-end encrypted channels, issuance of credentials, rotation of credentials, revocation of credentials. So it's identity and access management designed for IoT, rather than taking traditional identity and access management and trying to force fit into IoT. This is identity and access management designed specifically for what real world IoT looks like. And it's fully 100% open source, and it's available as a collection of developer tools. The idea being that a lot of this cryptography that we are using to do this is very complex, but the APIs we expose to developers should be simple enough and misuse resistance. And just like they should just work. I should be able to call a function and they say, create a secure channel with that light switch. I shouldn't have to figure out a bunch of complex cryptography to do that. So that's what we're enabling. We're enabling a very simple function that a developer can call to say, give me a secure channel to this other device, or from this device, give me a secure channel to this enterprise service, without all of the complexity that goes underneath in terms of creating that actual secure channel.
Yeah, it's been fun to watch you guys evolve. Been speaking to you for some time now, and it seems like every time we talk, you guys have a more kind of precise view of exactly what part of this you can tackle and how to do it, which is neat. So you've learned a lot.
We've learned a lot as well, right? And it's been obviously an exploration of essentially what we're taking is trying to do is take complex cryptographic tools that have been proven to work in other settings. So we're not inventing this stuff, right? There's already proof points of a bunch of this working, right? Like end-to-end encryption in messaging apps already works. So we're taking existing stuff, but we're applying it to the context of IoT and trying to solve this collection of problems that go into making a successful IoT solution without exposing the complexity involved in it to the application developer.
And if folks want to join your community and get involved in your open source initiatives, they can do that off your homepage. So Occam.io, join community.
Occam.io and GitHub. Yes, that's a perfect place. Or we have a discussion board on GitHub. So github.com/Occam-network/Occam. And I'll post a link in chat so everyone has it. Oh, maybe I can't do that.
Yeah, please do. You can. I'll post a link to your website as well.
And over there is, check out the source code or GitHub. So if you find us on GitHub, that's the best place for all conversations. And we are looking for use cases on how to build use cases where you're struggling with security problems, right? If you have an IoT solution and you care about the security and reliability of that system, I would love to learn more about use cases and tell you about, how these new protocols could be applied to those situations.
And yeah, there's a question you may not want to answer today, but how much do you charge for your knowledge a day for your knowledge and experience? You want to issue some pricing guidelines or?
Well, at the moment I charge nothing. Just ping me on Twitter and we can chat. I am so hungry to talk to people with real world problems. So absolutely, ping me and I'd love to learn about you, what you're doing, what kind of problems you're solving. So nothing. I used to be a consultant, and at that point I definitely did have a rate, but these days I'm not.
Yeah, I mean it's a cool opportunity to kind of build community around what you're doing, and then inevitably project work stems from that over time. But I like that you're focusing on the community side, because that's really what we need right now, especially as you say around the developer communities around this stuff. So
yeah, and it's open source is a key sort of value in the company we started. Essentially, we think that that's the only way to build a security-centric product, right? There's security by obscurity just doesn't work, right? Saying that my system, I'll just not tell how my stuff works and no one will discover the problems with it is just like, it's an unproven technique. So the better approach is just to, hey, this is how our stuff works. This is what our designs look like. Let's chat about what your problems are and let's see if we apply. And we're also pulling in cryptography experts and protocol design experts into the community and continuously getting feedback. We're also pulling in developers who tell us if this stuff is in fact easy. We want to make it easy, but is it easy? So all of that is very useful in open communities.
So aside from getting additional dialogue going on various use cases with people on projects, what heading into this next year, what questions are you trying to figure out? What you're a very intellectually vigorous person is trying to solve further problems. So what's next on your mind?
I'll share from Occam's perspective and personally. So from Occam's perspective, the big thing ahead for us this coming year is integrations with partners. So we already announced one with InfluxDB, which is a time series, open source time series database just a few weeks ago. We're doing another announcement with Microchip in in a few weeks. They're a major hardware vendor, and we're developing integrations with Confluent and Kafka, and we're developing integrations with Okta, the human identity focus business. And so the next year for Occam is all about integrating into existing enterprise infrastructure. We've built our thin layer that provides security, but we know that we can't exist in isolation. So our go-to-market strategy is all about integration with existing tools that IoT systems are already relying on. So that's what next year is all about at Occam. Lots of integrations. We call them add-ons. And personally, for me, I'm just curious about the world. So I've been learning, building Occam has led me into very deeply into cryptographic protocols. I started a cryptography meetup. In fact, just 2 hours ago, we had a meetup about multi-party computation, where a PhD student in cryptography presented how you could run a function between two parties without revealing the inputs of the function, but you only reveal the outputs of the function. So for example, John and I could compare if I have more pieces of, let's say both of us have a bunch of pencils sitting on our desk, we could compare whether he has more pencils or I have more pencils without revealing how many pencils each of us have, right? So it could be 5 or 10. The output that's revealed is I have more pencils. But whether it's 5 pencils or 10 pencils or 20 pencils, that part is not revealed. This is obviously a made-up example, but you could apply it to some real-world scenarios where you could reveal, the real-world use case the presenter was talking about was comparing two people's salaries without revealing the actual salary and saying who's getting paid more without actually revealing the actual amount. So there's some really cool cryptographic use cases. But essentially, what IoT has done, or this Occam project has done for me, is exposed me to this deep side of cryptography where there's lots of very cool tools to learn.
Absolutely. Well, those are really important problems to be solving. So I think it's been fun to watch your evolution to all of this, from where I've known you for a long time now. And, you were a classic SAP mentor back in the heyday, and, you found your way into some really fascinating stuff, and, stuff that I think is, technically fairly difficult, but I think it's really important too. I mean, we didn't talk about all the security headlines in this area, but, pretty much every day there's another one if you go out and dig for it. So really important. Really important.
And, like we said in the beginning of the episode, the digitization of physical things is not stopping. People are still doing it because they see value in it, right? We could do it the bad way and then suffer from a bunch of pain in a few years, which already is exasperating, right? It's the IoT attacks from 4 or 5 years ago started with just becoming part of a botnet. And then a few years later, they became ransomware related. And then a few years later, like last year, there was the Triton malware, which is essentially attacking safety critical systems like grids and chemical plant, energy grids and chemical plants, and it's blocking their safety procedures, right? So the escalating threat is happening, and adoption is also happening. So it's intuitive to assume that this will lead to some really bad stories in the future. So it's we can just let that happen, or we can build tools that make it so that those kinds of things don't happen, and we have better systems.
Very well said. That's a good note for us to end on. But I am going to work in this final comment. Final question: could the police use this to create speed cameras that are more efficient? And he says, I recently got a speeding ticket and thought, wow, this could have been so much worse if I was in charge of the technical side of cameras, photography quality, etc. I assume the answer to that question is basically yes. Basically, there's a lot more that they could do there. And
I think vision is a really complicated area, right? There's obviously a lot of cameras permeating everywhere around us, right? And how those systems are built, I think it's on the designers of the systems to build those systems correctly. This police example is an interesting one. I always give the doorbell example. The contract of a doorbell is, I buy a connected doorbell. The contract they sold me, like the expectation they sold me was, I can see who's at my door, right? But the reality is they can see who's at everybody's door on my street. And that's not a good ethical system designer that built that system, right? Ethical system designers need to build systems that serve their customers the right way. So I think vision's a really interesting, challenging problem space. And I hope more people will go towards the more ethical, serve my actual customer line than, the Orwellian surveillance situation.
Yeah, absolutely. I actually have a related article on that coming out on Diginomica next week, and I totally agree with you. And I think there is this sense in which we buy a lot of devices and we participate in a lot of systems where we're not really told exactly how much access to our data they have. I mean, I think about like some of the smart devices I have in my home. I'm not going to say their names, so I don't want to start talking to me right now. But I found out over time just how much they're intruding upon me and how much they're recording and listening. And, it was something that I would have been a lot happier if I'd known up front, rather than like going in and having to lock certain things down and turn certain features off. And to your point, there's an ethics and design here. And, ideally that will be honored, because then we can have a legitimate conversation about this technology making our life better, instead of having to revert back to this Orwellian discussion all the time, which unfortunately seems to be prevalent so often. So, but that's a whole nother program, and I think we've done our time today. So it was a real pleasure talking with you. It always is. I thought you really framed this nicely. So it was really, really fun today. Thank you.
Thank you. It was amazing, and thanks everyone for joining. That was awesome.
Absolutely. Yep. Glad you managed to make it too. We'll catch you again soon. I'm hoping to do one more next week before I take a break for a week or two for the holidays. So hopefully I'll have something next week. I'm not sure yet what it's going to be yet. So I still got a little work to do there. Thanks, everyone. Catch you next time.
Thank you, Ron.